So let's say if you don't know, you have arrived at the Norwegian.net user group. We are part of the .NET Foundation, and we are an independent user group with a focus on .NET. And our slogan is by developers for developers. And if you want to reach me, we're always interested in people that want to share their knowledge. So if you have something that you would like to present, you can contact us in any of these ways, either send us an email, reach us on Twitter or YouTube, and so on. And we also have a YouTube channel where we are posting all of our meetups. So we're doing a recording of this meetup, so we'll put it up on our YouTube channel in a while. And we would also like to thank our sponsors, because our sponsors are the ones who make these kind of events possible, so that we both can have, the pizza, and we can also have somewhere place to host these kind of events. And this is the current board or the current organizers of the Norwegian.net user group. So we have this blue thing usually on our events. So if you see any of us, just grab hold of us and ask us any type of questions. And as a matter of fact, we are actually right now we're looking for more new board members. So if you're interested, you can send us an email, send us an application. Doesn't have to be super long, but just describe who you are and why you would be a great fit as a board member. And if you want to know more, you can check out this post on LinkedIn where we give you a little bit more information. And we have a deadline here of the October 30th, and after that we will do a selection. We'll contact the applicants, and then we'll announce our new board members by the end of November. So really looking forward to some applications. And in addition, we're also sponsored here by Microsoft Norway. So if you take out your mobile phones, you can scan this QR code, and then you will learn more about how you can have automatic updates in a web app using Azure Functions and SignalR. And we also would like to encourage you to be an active participant here in the evening. So we will give away a Microsoft backpack for today's best technical question. Den vita. Oh, denna. And this is the agenda here for today. So the first item we have already finished, but there are still lots of pizza left. So if any one of you are hungry, you could just go ahead and have some more pizza. And the main topic here for today is the event-driven development in Azure with SignalR with Laurent. And we will finish here with like a 10 minutes. So that will take around an hour, and then we'll finish with a Q&A session here. So just some introduction here to Laurent. So he works as a senior cloud developer advocate for Microsoft, and he has spent more than 10 years working for IdentityMine and Valorem, that are two leading firms in Microsoft technologies. And he codes in almost anything that there is to code in Azure.NET, Windows, VPF, Xamarin, and ASP.NET. And he also writes for technical publications like the MSDN Magazine, and he has videos both on YouTube, on the Microsoft Channel 9, and so on. And he's a frequent speaker at big conferences like Microsoft Ignite, Microsoft Build, TechEd, VS Live, and Techorama. So Laurent, are you with us?
I am here, and I believe you can hear me, and I'm also sharing my screen, so I hope you see it.
Yes.
Okay, I think I can see my screen in the back, and I'm going to see my mouse probably. Do I see my mouse? No. Anyway, it's actually cool that I can see people. I wish more user groups would do that, because you know how it is talking to a camera is no fun, and especially when I hear there is pizza involved, and it's kind of, I'm in the same time zone as you all, so it's actually dinner time here. I will have dinner after the presentation. So anyway, I guess I can take it up. Perfect. All right, wonderful. Well, thank you so much for joining today. I'm so happy to see people in person in a room, listening to a user group. You know, it's fantastic. I was 2 days ago in an in-person conference here in Zurich, which is where I live. We had .NET Day, it's called, and it was great to be in a conference. I've had the chance to have a few in-person conferences this year, not as many as I did pre-pandemic, but nonetheless it was really a good feeling. Talking to a camera is difficult, so I hope you cope with me. Sometimes it's hard to know if the jokes land, if people understand what I'm saying. But nonetheless, I still do it for user groups because I think it's really important to support user groups. And I know firsthand how difficult it is to find speakers for user groups. So if you have anything that you feel is interesting to talk to people about, or even if you don't think it's interesting, believe me, whatever you do in your work is interesting for the people to hear, because they probably have similar issues, right? So by all means, please submit topics. I started, speaking in public in user groups long time ago, and I was lucky enough that I loved it, and apparently people liked my content well enough that I was picked in conferences later, and that leads to a lot of things. But starting in user groups is the best place that you can do. So I'm definitely happy to be here and support this. All right, so long story short, I want to talk to you about event-driven applications in Azure. And so essentially what is behind this talk is, with the pandemic and everything, I've reduced the number of talks that I've been doing. But nonetheless, I was lucky enough to work on super exciting stuff, nice applications that we use internally at Microsoft to produce some of our shows. I write a lot of automation code these days, everything running on Azure. And at some point, I had the idea of doing an application called Timekeeper. We'll talk more about it a little bit later, which I showed to my boss. My boss loved it and said, hey, we absolutely need to use that a lot at Microsoft. And that kind of presented me with a lot of issues, because when you have a small application that you're using on your own, you don't care about security so much. But then suddenly when a lot of people at Microsoft are using it, you need to be very careful what you're doing. And so I had to ramp up the security and everything on this application. We'll talk more about that, but I just wanted to show you a little bit the principles behind that. We're going to build together a fun, simple application using SignalR, Azure Functions, and that should be fun, hopefully. So the technologies that we are going to use tonight, I don't know if you recognize all those logos. The first one on the left-hand side is SignalR. We'll talk much more about SignalR, understand what it is and why it's been even developed by Microsoft. Then we'll use Azure Functions. We won't talk too much about Azure Functions because it's like a whole different, topic. But Azure Functions are definitely very useful. And nowadays, it's very rare that I deploy anything that doesn't use at least one Azure function. We'll also talk a little bit about static web app. Strictly speaking, Azure Static Web App don't have anything to do with event-driven application, but they're probably my favorite service on Azure these days. I really like Azure Static Web App, and so I thought it was interesting to spend a few minutes talking about them and understand how they are going to help us achieve our goal today. Timekeeper itself is built in Blazor. Blazor is a way to build WebAssembly applications and basically WebAssembly applications, let's say, using .NET. As you probably know, WebAssembly is a standard. It runs in most modern web browsers, I would say, including on phones, by the way, which means that Blazor can be a good alternative to Xamarin /.NET MAUI if you want to build cross-platform applications. Of course, it also has restrictions of the web, right, in terms of sandbox, etc. But for many tasks that you do, it's actually pretty cool. And so I built Timekeeper using Blazor. It was also a way for me to dive deeper into Blazor and understand what it does and how I can use it. The demos that we're going to do tonight, we are just going to use JavaScript, HTML, and CSS. almost no CSS, to be honest. Mostly just HTML and some JavaScript. And I'm going to be using Vue.js, which is a lightweight framework, which allows you to do some cool things, especially around animations and stuff like that. It's almost vanilla JavaScript, if you want, just to illustrate the point. But Timekeeper itself, which we'll talk more about in a moment, is built using Blazor itself. All right, so on the agenda, we will talk about how we did in the past when we wanted to have event-driven client application development in the web with JavaScript. We had tricks and tips, and maybe some of you are old enough to remember those days, and so that's kind of a blast from the past. But then we'll talk about also what is modern, and WebSockets are definitely where it's at. SignalR is, a service that we have, and we'll talk a little bit more about what SignalR is and how you can deploy it. We'll publish our demo to static web apps. So that should be a fun part. Like this, it shows you also a little bit more of an overview. And then I'll talk about Timekeeper, like I mentioned, this application that I developed and which was kind of the inspiration of this talk. So event-driven client-side JavaScript in the past, essentially in the early days, and I'm talking here, when we are doing early JavaScript development, essentially at some point we got a really cool toy from Microsoft, which was called the XML HTTP request. And so essentially this is an object that you can call from JavaScript, that you can interact with in JavaScript, which allows you to do to SPA, right? To single page applications, where essentially a SPA is, okay, it says my internet connection is unstable. I hope it's not true. I have like a very fast connection. Anyway, so SPA essentially are an application where, there is always a lot of web calls in the background, and then the screen is updated using that. And back then, of course, the only way we could do that was by calling the web server periodically. And then the web server could say one of two things. It could say, oh, I have indeed a change for you since last time you called me. All right. And then the web browser would be updated. Or it would say, no, I have nothing, try again later, essentially. And of course, this is not very satisfying because especially it introduces a lot of latency in this whole mechanism, right? Which means that at best, like let's say that you poll every 30 seconds, at best you get, a reply pretty fast, but at worst you will get a reply 30 seconds after the event actually occurred. So it's hardly real time. Another thing which is of course annoying is that you keep polling the web server even if nothing changed on the web server. So you're overloading your web server even if nothing changed, which is of course not ideal, right? But really the latency was the most issue. And so what can you do if you want to reduce latency? Well, you can say, all right, instead of calling every 30 seconds, I'm going to call every 5 seconds. And that doesn't work well because of everything that is involved in calling the web server, getting an answer back, etc. Back then, we kind of settled on 30 seconds as a minimum time that you could have between two requests. So not very satisfying. So then some very clever people came with an idea which was called Comet or long polling. And I don't know if some of you are familiar with that. It's actually pretty clever. Essentially what it does is that you place a request to the web server, but the web server is configured to keep that request open until one of two things happen. It can either time out or something happens on the web server, an event that it needs to give back to the web browser, in which case it returns the value to the web browser. And when the connection times out, what the web browser would do is immediately reopen a connection. So essentially, it's as if you have a direct line of communication with the web server, which is always open, okay? Which, of course, the advantage is obvious, right? It means that when something happens on the web server, immediately you can notify the web browser, which is cool. And also, it works everywhere because it's a simple HTTP request response mechanism. So it's absolutely standard HTTP there. But of course, it also has some issues. And one issue is that keeping a connection open is also going to load your web server quite a bit. So if you have one client, it's not too bad. If you have 1,000 clients or 1,000,000 clients, that can be a little bit tricky. And again, those connections have to, be kept open even if nothing happens. So it's kind of a waste, right? You're wasting resources. Back then, when we were doing Comet in the, what was it, like early 2000s, I guess, one of the problems is that the web browsers back then would support only 2 concurrent connections open. And when you had Comet, you were using one of those connections just for updating your window. And for everything else, you just had another connection open. So you would lose 50% of your connections. Now, I'm told that these days, web browser can support more open connections. I heard 4. I'm not sure if it's true. I'm not like the biggest specialist here. Nonetheless, it was a little bit tricky. Generally speaking, Comet always gave me a feeling that, well, it's kind of a workaround. You're kind of simulating a server to web browser, the server to client request, which it was not, right? It was really just a reply, just a response. So not great, but it did work. So we were using it. So later came WebSockets, and WebSockets are really cool. WebSockets, first of all, they are not new, right? You see, they were published, the RFC was published in December 2011. So it's a long time ago, right? It's almost 11 years ago, okay? So it's not totally new, but it's very innovative. And so what happens there is that it all starts by a standard handshake, a standard HTTP request response. But then there is a connection which is opened and persistent between the client and the web server. And this connection is bidirectional, okay? So it means that your client can communicate with the web server through this connection, but the server can also send a message to the client through this connection. So that's pretty cool. It's a full duplex communication system, all right? It goes in both ways. And it is, which is great these days, supported by most modern web browsers, including, Chrome, Firefox, Internet Explorer. I'm not sure it's really a modern web browser, but I added it anyway. Edge, and also, by the way, on phones, on mobile phones, which means that when you use WebSocket and you develop something on your, on your desktop, basically, if you open the same page on your phone, it's going to work as well. There is also a secure version of the protocol. So the WS is a WebSocket protocol. And then you have the WSS, which is WS Secure, which is using SSL, just like a standard HTTPS connection uses SSL, or these days TLS probably, to be encrypted. So this brings us to Azure SignalR service. SignalR was developed by the .NET team, the ASP.NET team, the team that creates, the web framework that is very popular within Microsoft and used by tons of people outside of Microsoft as well. And it was essentially developed initially as an extension of ASP.NET. So what you would do is that you would have a web server, and then you would add the SignalR component to that, and then suddenly your web server was able to handle WebSockets connections, and then after that you had on the client different SDKs that you can use with JavaScript, with .NET, with Java, etc., to actually start the whole WebSocket communication process. Now that's really cool, but even better, now you can host it as a serverless service on Azure, and we'll talk more about that. SignalR was developed specifically for system where you want to have high frequency data updates, right? When you have some gaming, when you have, a poll, when you have, somebody is voting and you want to be notified about the results as soon as possible in real time and with high volume of data being transmitted, right? So an auction and this kind of thing. Essentially, every time you have a dashboard, something that needs to be updated pretty often. Chat is kind of the canonical sample application. We'll do a chat later, but there are also tons of other things you can do with SignalR. Collaborative applications, push notifications, but not in the sense that you have a push notification on your phone. That's a totally different system. It's different on Android and iOS. And also push notifications in your application are not going to work when the application is in the background. In this case, if you want to have push notifications on mobile while the application is in the background, you really need to use the system that you have in Android or in iOS for push notifications. But when the application is running, then, okay, you can use SignalR to do push notifications. Real-time broadcasting of anything, etc., etc. So a lot of usage. As soon as you want to have a system where the server needs to be able to notify all the clients in as real time as possible, SignalR is a good choice for you. Note that it's not the only way to do event-based applications in Azure. Okay, this is one of the ways. It's a way which is probably the closest to .NET, I would say. So it's good for us. But there are also other services that we have which allow you to do that. So let's talk about the hosting model. So like I told you, initially, SignalR was developed as an add-on, if you want, to your ASP.NET web application. And so you had to host it into a web server. And this web server could be potentially an Azure App Service, which is essentially a web server in Azure. But you could also host it on your own web server that is running under your desk at home or at your office. However, of course, it forces you to deploy a web server and with all the costs that are associated to that, which is why it's very interesting for us now to have a possibility to have an Azure SignalR service, where essentially it's a managed service. Okay, it's I guess you could say it's a platform as a service, but actually it's so close to serverless in the way that it functions, because essentially you deploy it and then you kind of forget about it, right? You get a connection string and that's all you do. So I personally consider it's really a serverless system where I don't have to worry about the server ever, pretty much. Nonetheless, it is an Azure service, and so it offers you all the monitoring systems that you can imagine. You know, checking if you have some errors, if you have some, you can get notifications when it's down, etc., etc. So it's pretty good. So the way that you do is that you say, all right, I want to have my web clients. Those are going to be web browsers or something like that. You have your service. You can have multiple instances if you want, and then you have somewhere. Can be a web app, or it can be something else. We'll talk about that in a second, which is communicating with this SignalR as a service. SignalR, the client SDK, works on multiple client types. For example, .NET SDK, so you can use it in Blazor like I did. You can use it in Xamarin if you want, in MAUI if you want, in WPF for that matter. I mean, any .NET client application can use that. You also have a JavaScript SDK, which you are going to use in the demo that we'll do in a moment. There is also a Java SDK. And also it is standard based. And so you can also actually communicate with your SignalR service using REST, which is every Azure service has a REST API. So the SDKs mostly are actually a wrapper around those REST APIs. So if you don't have .NET, JavaScript, or Java, if you have something else, but you can place a REST call, you're okay to work with SignalR. A mobile client, like I said, you have a choice because of all those SDKs, Xamarin, MAUI, a native Java if you do some Android application, for example, Blazor, JavaScript, or REST, like I mentioned. Now, the cool thing with SignalR is that there is also a fallback mechanism. So like I told you, if your web browser is modern and healthy, it's going to support WebSockets, right? So that's cool. But if it doesn't, the SDK is going to try something else, which is called server sent events. I wasn't aware that it existed before I prepared this presentation. So it tells you it's not like super well known. Maybe some of you have used it. It's basically a protocol that some web browsers support, where some web browser and web server support, where the web server can send an event to the web browser. But at the bottom, if your web browser doesn't support that, at the bottom, we can also fall back on the long polling mechanism that I mentioned before, which works pretty much everywhere. Now, of course, if you fall back on long polling, then you have, again, the disadvantages that I mentioned, such as, for example, having to keep a connection open at all time, even if you're not actually using it. So keep that in mind. To be honest, these days for standard apps that you develop in, except for very rare cases, I would say that the SDK is going to be supported everywhere, and WebSockets are a standard supported by everyone in the industry, which is pretty rare, which means that it's going to work pretty much everywhere. All right, so it's time for a demo. So for the demo, what we are going to do is build an application. I told you the chat application is kind of the canonical example that you can do. It's kind of exciting, not super exciting, but the cool thing is that everything I'm going to show you now, both the C# code that we are going to do in the Azure Functions, as well as the JavaScript code we are going to do in the web, you can use that to build other applications. Also, a quick word about the tech I'm going to use here. I'm going to use C# on the server for my Azure Functions, because this is kind of where I feel at home. But everything I'm going to show you can be done also in JavaScript, in Java, or in other Azure Functions languages. On the web, I'm going to use JavaScript in that case, but later I'll show you also quickly some of the code of Timekeeper, where you'll see that the code in C# is very similar, the client code. Okay, so just to be clear about that. All right, so I prepared here a solution, and I have two components here, two projects. I have a function project, which is going to run on the server, and then I have a web server here, which is my client. But I told you before that you can deploy SignalR without having a web server. And in fact, it's true, I don't want to have a web server to maintain in Azure. So the reason why I have a web server here, I'm just going to use it for test, just so that I can run localhost on my local machine for test. But later, when we deploy to Azure, we are not going to deploy the web server, because everything I need is inside this single file, index.html. Okay, this file is going to call to load a few other JavaScript files, but essentially the code we are going to run now on the client is purely client side, doesn't have any web server component. Okay, the only thing that is running on the server is the Azure function, and Azure functions are a serverless component, so I don't have to worry about the web server so much. All right, so let's start with the chat server. And I'm going to set it as a starter project. And then I'm going to add an Azure function to that. And this Azure function is going to be called negotiate. Okay. So this Azure function, what it's going to do, it's going to get an HTTP request. I'm just going to not protect it at all. If you were deploying it in normal conditions, you would probably protect that. But here I'm just going to make it anonymous, okay? And whenever the request comes, the request is going to be a GET request. So I'm going to configure my function here. I'm going to say, all right, this is an anonymous call. I only want to support GET, so I'm going to remove the post here. And for the route, this is part of the URL. Okay, so you're going to have your web server /API/ and then what I'm typing here, which is negotiate. Cool. And then as part of my Azure Function Framework calling this method, I'm going to get the HTTP request there. So that's cool. Now I need to change the return type. So I'm not going to do a task here. So it's not going to be asynchronous call. It's going to be actually a synchronous call of the function. And I'm going to return a SignalR connection info. What is that? Well, it comes from a NuGet package that I installed. Okay, so NuGet, for those of you who don't do .NET, this is the .NET. Well, actually, it's a .NET user group of Norway. So I guess you know what NuGet is. But essentially, it's a package manager. And right here, you see I have Microsoft.azure.webjobs.extensions.signalr service. Okay, so this is where this SignalR connection info comes from. I'm going to add the using. All right. And of course, I need to obtain that from somewhere. And one way to obtain something from somewhere with Azure Functions is to use what we call bindings, input bindings or output bindings. And in that case, I'm going to add here a parameter in my function signature. And this parameter uses this attribute SignalR connection info to do some magic. All right. The magic that happens here is that the function here, or rather the framework, before the function is even called, is going to try to connect to my SignalR service, which, by the way, here at this point, I didn't say where the service is located. All right. We'll see how we do that later. That's kind of part of the magic that is happening. But nonetheless, I'm going to configure all that so that it finds the SignalR service. Then it's going to say, all right, I want to have a hub called Simple Chat. A hub is like on a service, you can have multiple hubs, okay? And then please give me the connection info for that. So again, a little bit of magic happening here. This is what input bindings do in Azure Function. You can have input bindings for all kinds of services, things like blob storage, queues, what do we have, etc., essentially Cosmos DB, etc. And then when I have this connection info, I'm just going to return it to the caller. That's all I do. Okay? Easy. Again, keep in mind, I didn't tell the configuration a little bit later. So now we are going to add another function. And this other Azure function, I'm going to call it talk. This is also going to be an HTTP trigger. So it's also going to be triggered by the client when the client wants to say something to everybody else. And so for this function, I'm also going to format that a little bit. Actually, this function will have a payload because this is going to be the message that we want to send. So it's going to be a post, and I remove the get. Get doesn't make sense in this case. I'm going to say, okay, the URL is going to be /API/talk. And here, what I want to do is whenever I get the message, I want to add this message to give the message to the SignalR service. And the SignalR service is going to take care of sending that to everyone, which is subscribed, okay? And so the way that we do that, we can also do that with an input binding, which means that I'm going to, before the function is even called, my Azure function framework is going to connect to the SignalR. It's going to say, hey, I want to have a queue of messages that I'm going to add to this simple chat hub. And this queue is here. It's an async collector. Essentially, it's a queue of messages. And what the function is going to do every time it's called, it's going to add the message to the queue. And then it's going to be automatically sent to the SignalR service, which is then going to dispatch it to everybody subscribed. Okay? So in order to do that, first of all, I'm going to put a try catch because I want to avoid if, for example, my JSON is not properly formatted, etc. I'm going to read the message from the request. So here I do that with a dynamic. You could do that in different ways, of course. And then essentially, I'm going to check what is inside. I am expecting a name, which is the name of the sender, and a text, which is the text of the message. And then I'm going to wrap that in a J object, which is a JSON wrapper, if you want. And then I'm going to add this message here to the queue. So I'm going to create a new SignalR message. I'm going to give it a target. Remember that because later we'll see in the client what target does. Essentially, like I said, you can have one service. You can have multiple hubs in the service that different people subscribe to for different usages. But within a hub, you can also tag your message with a target, which means that after that, the client is going to use a target to say, all right, so if it's a new message, I'm going to do that. If it's a delete message, then I'm going to do something else. If it's an edit message, I'm going to do something else, etc., etc. And then the argument of that SignalR message is this object that I have wrapped, which has the name and the text. And then I'm going to just return OK object result, which says essentially I'm returning HTTP 200 with a little bit of payload saying, all right, so this is your name and this is your message. This one probably is going to be totally ignored by the client, but it's just nice to return 200. Okay. All right, so now at this point, we could try to run the code, but as I told you, there is still a little bit of configuration that we need to do, because right now we don't know where this SignalR lives. And the way that input binding work in general is via an environment variable. So they need a connection string. The advantage of that is that it's pretty cool, because it's going to allow me to create here this file local.settings.json. This file doesn't go in GitHub. All right, I'm going to put it in my git ignore. And it means that every secret that I have is going to be kept on my development environment. And then after that, when I deploy the functions to Azure, then I'm going to have some secrets in Azure, but not in the code. It's not in GitHub. Okay, and that's important, because if you do a search for connection string in GitHub, you will find thousands and thousands of connection string. You don't want your connection strings in GitHub. So here, the connection string are staying on my developer environment. Another advantage is that I can have a totally different connection string on my developer environment than in Azure. And this allows me to have a developer environment with a different SignalR service, a different database, and a different everything. And then I can have my production system where I only deploy once I tested everything. So this is the structure of a settings file for Azure Functions, all right? I'm going to add, and this is where the magic happens, I'm going to add a variable which is named, this is kind of a code name, Azure SignalR connection string. And this is what this binding here, well, this binding here really is looking for. And this is what this binding here is looking for. So important to have this value here. Now, what kind of connection string do I need? Well, this is when we go in Azure. This is a SignalR service that I deployed, which we are going to use for this demo. And as you can see, I get some really cool things like monitoring. All right. So in the past 30 days, I didn't use it much because I didn't do this demo in quite a while. But notice I did use it not that long ago, because I did test my demo to see if it was still working. So today, around 3 p.m., which is UTC, so around 4 p.m., I actually went and deployed everything to check that everything was still working. Okay. So this is cool. I have some monitoring. I have all kinds of things that I can do, some alerts, some metrics, some diagnostics and things like that. Basically, it's a standard Azure service if you want, including here a connection string. So I'm going to copy that connection string. And then after that, I'm going to go and put it here. Again, keep in mind that this local.settings.json doesn't go in GitHub. So it's okay to have secrets here, but you want to be careful with what you do here. Another thing I'm going to do, I'm going to add here a CORS directive, because if it's not DNS, it's CORS, right? So if DNS doesn't cause your application to fail, CORS probably will. Essentially what we do here, when we deploy later to Azure, both the function application and the client, which is here in my index, are both going to run in the same domain. So I don't need CORS when I deploy to Azure. It's all in the same domain. But here, when I test my web, my debug, my test web client or web server here is going to run in localhost : and I'm not even sure where it's running. It should be somewhere in web, I believe. It's going to run in 51981, right? Localhost, and then the port is 51981. And my functions are going to run in 7071, which is the standard port for Azure Functions. So from the web browser point of view, it's a potential risk for attack. And so here, what I do in my local settings.json is essentially I'm saying, I'm going to allow everybody to access those functions. And this way, I'm kind of disabling CORS here. You probably don't want to do that in production, but it's just for test here, okay? Good, so now I have configured my stuff. So let's see if it works. So I'm going to run my chat server locally here so that I can test everything. All right, we have the console opening. I see my two applications. The first one is a get, the other one is a post, my two endpoints, if you want. So now I can take here, negotiate, and I'm going to try to put that into a web browser. And I see, that's pretty cool, I'm getting some information. This is a SignalR connection info, which is JSON encoding. It has two properties, a URL, which is a URL of the hub. Remember, the hub is named Simple Chat, and it has an access token. And this access token is going to expire after a while. Okay, so what you need to do is that every time you start your application, you're going to ask for the access token. So you're going to negotiate. Then you're going to use this value to open a WebSocket connection. I'll show you how to do that in a moment in the client. You're going to talk. You're going to send messages to everybody. And then at some point, it's possible that when you try to talk, that it's going to fail. Actually, you get an event in the SDK telling you that the connection has timed out, and then you have to negotiate again, and then you're going to get a brand new token from the server. So it's very clean and very nice the way it works. All right, so now I can accept that my functions are working. I'm going to let them run, and now let's worry about the client of our chat server. So the client, like I told you, it's going to run here in a web browser just for test, but essentially what I'm going to deploy to Azure, you know, what's going to be served to the client is just this HTML and JavaScript, okay? So we have here a title. Here I set the window, I set the base URL for my function. Later, when I deploy to Azure, this is going to be an empty string, because everything on Azure is going to run in the same domain. So I don't need to have that. But here, because I'm testing here and I have my functions running in 7071, I need to specify that. I'm using Vue. So with Vue, you can do some nice animation. So essentially, this is what I define here in CSS. And then I will have a bunch of things here. I will have a row, okay, a div, which is data bound. Remember data binding in XAML and all that? Well, you have the same kind of things in Vue.js. I can data bind to a property. And here I say, if ready is true, then I'm going to show this. Okay, so it's kind of nice in Vue. You can do these kind of things. Where does this ready come from? If I scroll down here, you see I have this object, this JavaScript object, which is called data, and it has a property called ready. And then at some point, I'm going to say, when I create my new Vue application, I set this data object, which is here, as the data property of the Vue application, which means that it becomes the Vue model for my application. Which means that after that, I can do some binding. And again, this is exactly what I'm doing here. I say, if ready, I want to show that. What I show if it's ready, I'm going to show a form. And inside this form, I'm going to get a message from my user. This message is here. I data bind it to a property of my Vue model, which is called new message. Okay. I configure here a few things, placeholder, etc. And then I say when you press enter, that's when you submit the form. I'm going to prevent the form from being submitted, but instead I'm going to call this method, which is called send new message. And I said method even though I'm in JavaScript, because this is actually a method of the Vue model. And again, this send message is defined here as a method of my Vue application. And we'll see later what it does. Okay, then if it's not ready, okay, I'm going to show a message saying loading. You could have a spinner or whatever you want, but essentially that appears if I'm not ready yet. Now, if I'm ready, I'm going to show all the messages in rows. And to do that, I'm using an object called a transition group, okay? And inside this transition group, now this is an object that Vue can handle. Inside this transition group, I have a row. And now what I say is I have v-4. So I say for every message in the messages array, which is part, like everything else, of the Vue model, I'm going to show one row. Okay, so you see, it's kind of neat, right? It automatically, every time I add a message to this array, Vue is going to take care of showing that. And what it's going to show, it's going to data bind with this kind of wacky syntax here with a double curly bracket. It's going to bind to, I have this object message, to message.name. So if you remember in XAML, that's the equivalent of doing a data binding to a list, to an observable collection, okay? And then after that, you have inside the row, inside the object that is displaying the row, you're going to be data bound to one of the items of this observable collection. And then you can have here the name and the text. So it's pretty convenient, it's pretty cool. Then I have, of course, to download a few things so that it works. I'm going to add view.js. I'm using an old version here. I don't have really a reason to change it. It wouldn't improve the demo if I changed it. It does work well. What's really important is here the SignalR.js, which I'm downloading here. This is a client SDK in JavaScript. So here I'm using it from this CDN. I'm downloading it from the CDN from NPM. Later in Timekeeper, you'll see that because it's a .NET app, I'm using NuGet. And I'm also using this package called Axios. I could do it without because essentially I have access to the XML HTTP request object that allows me to do web requests. But Axios is pretty cool. It's an HTTP client, which is easy to use. All right, so now let's see a little bit later. Here, this is some function definitions, okay? So I'm going to call, I need the connection info so that I can open my WebSocket connection. And this is going to happen here in this function. I'm going to use this Axios HTTP client, and I'm going to call get. And I'm going to call the negotiate function, which is still running here. Later, it's going to run in Azure. When this comes back, I'm going to call here, I'm going to say then, and then I'm going to pass back the data object of this call to the caller, okay? Remember, this is essentially what I get when I call here, when I call this, when I call negotiate, okay? Here. So essentially the data package is going to be this object here, which has a URL and has an access token. Then we are going to have another function, which is called when we want to send a message. And when we want to send a message, we are going to do a post to the talk function. Okay, and then we are going to give an object with two properties, the text and the name. And if you remember in the code, when we have the text and the name into talk, okay, we expect the text and the name, then we are going to wrap it, and then we are going to give that to SignalR. Then after that, this is what happens when you receive a new message. And I'll show you in a moment how it's configured. When I get a new message from the WebSocket, I'm going to get the message. I'm going to configure here an ID. This is because of the transitions, the CSS transitions that are happening. Every message which is shown in the list needs a unique ID. So I'm simply going to add a counter and increment the counter. Super easy. And then I'm going to add the message in the array. Apologies. But I'm going to unshift, meaning that I'm going to put the message on top. Why do I do that? It's because I'm lazy. Sometimes it's allowed to be lazy. I just want the message to always be visible, the latest message, but I don't want to scroll programmatically and add some complexity to my application. So instead, I reverse the order. I put the newest message on top. Okay. It's not really what chat applications do in general, but I'm not trying to compete with WhatsApp here. I'm just showing you how it works. All right, now I'm going to start my application to actually run the code. So I say, okay, enter your username. Then I'm going to save that in the view model. Then I'm going to call get connection info, which is calling my negotiate method. When this happens, when this comes back, I'm going to take the info, that the data, that the URL and the token, and using this, I'm going to create here an access token factory. It's just the way that the SDK works, but essentially I'm going to return the token whenever I need to return it. And then I'm going to use here the hub connection builder, which comes from the JavaScript SDK for SignalR. I'm going to say with the URL of the hub, and the options which contain the access token, I want you to build the connection. At this point, the connection exists, but it's not opened yet. Then I'm going to configure my connection. I'm going to say when you receive a target called new message, then I want you to call this function get new message. So this one deserves a little bit more explanation. Remember the target here, this is the same target that I have in the talk function. I told you, you can have a service, you can have multiple hubs in a service, and within the hub, you can have multiple targets. And that allows you in my client application, here I just have one target, but later for Timekeeper, I have something which happens when I start a clock, when I stop a clock, when I delete a clock, when I create a new clock. Those are all targets, okay? Get new message. This is the function I showed you before. When I get a new message, I'm going to add it on top of the array. And then Vue is going to update the UI. I also specify what happens when the connection closes. Here, I'm just going to log something, but in a real life application, in a production application, you would probably either ask the user, hey, the connection is closed, do you want to reopen it? Or you can just reopen it automatically so that the connection is always open, all right? Probably you want to try a couple of times within a short amount of time and then fail because you don't want to always keep trying in case the service doesn't run for some reason. Something like that. And then after that, I'm going to start the connection. And so from this time onwards, the WebSocket connection is established with the web server, and then I can start receiving messages. Okay? Cool. So this is how it works. So now we can actually try it. My functions are still running. Now I can start my application. I have to enter a username. So I'm going to enter Laurent. All right. A little bit big, so I'll make it a little bit smaller here. And for the sake of the demo, what I'm going to do is that I'm going to open another one of those windows. And then I'm going to use, actually, why don't we make that even more interesting? I'm going to use a totally different profile, which means that here it's totally separate, right? So I'm going to use here another one. This is live, it's my live profile. Both of them are open. And I can say, hey, how are you? And you see that it works. I receive the message. I am great. Boom. And so it works both ways via my SignalR service. Now, this is awesome because it means that I can chat with myself, which is cool because I always agree with myself. So I at least, you know, recipe for success of Twitter and everything. If you have only one user, you know, nothing bad happens. That's great. But of course, it's not super interesting. So what we want to do now is deploy that to Azure. And in order to deploy to Azure, we are going to use a static web app. Now I'm going to start the deployment, and then we'll talk about static web app, and I'll explain you what it is. So to do a static web app, I'm going to go into a resource group here that I already created. I'm going to create a new service. Okay. What did I type? Oops, I didn't type anything. Static web app. Okay, and here I have the static web app that I want to use. Okay, I'm going to say I want to create it. I'm going to have to enter some information like everything you do here on Azure. I want to create that. Oh, interesting. It actually didn't select the. Well, it kind of said, oh, okay, it selected another subscription. Let me just, okay, so I'm going to use my own subscription. Okay. Resource group, well, in this subscription, I have my SignalR demo resource group. It's actually empty. Otherwise, you could create a new resource group. Resource group is just a logical grouping of resources that belong together. And then I'm going to enter here a name, and I'm going to say this is my test chat. Test chat is actually test chat is okay. This name needs to be unique because it's going to be a URL at some point, okay? But apparently test chat is not taken, so that's pretty cool. Then you have different plans that you can choose. So if you have a hobby or a personal project, and that includes, by the way, running a user group, etc., you can use it for free. Or if you have really a production application and you need something more robust, you can use standard. To be honest, even the free plan is pretty cool. Like you can have, as you can see, there is no difference in the bandwidth. You can have 2 custom domains per application, 5 if you pay. SSL certificates are free, which means that your web application, your static web app is going to run in HTTPS, and we automatically renew those. So you never have to worry about that ever again. Even in the free plan, we give you an SSL certificate, well, TLS really. Custom authentication and private endpoints, you only have if you pay. And then maximum application size, you can see it can be twice as big. To be honest, applications that run in static web apps typically are very small, because everything that is bigger than a few kilobytes, you would probably put that into a blob storage. So images, videos, documents and stuff like that, you would put probably in a blob storage, and your application really just have, HTML, CSS, JavaScript, and that's pretty much it. And one thing which is cool is that you can also have staging environments. And the way it works is that, I need to pay attention to the time a little bit. The way it works is that you'll see that we'll have automated deployment via GitHub, via an action. And in GitHub, you're going to say which branch you want to automatically deploy. But in GitHub, whenever you create a pull request next to that branch, your static web app is going to create a staging environment automatically and deploy your new code there. Then you can test it. It's a different URL. You can test it and everything. You can even specify a different database for that, a different SignalR service and everything. Configuration is separate. When you're done and you're happy, you merge the pull request in GitHub. That's going to automatically deploy to your main branch. And that's also going to delete the staging environment. So it's really cool. You can see, even if it's free, you can have 3 staging environments, and you can have 10 if you pay. Okay. Functions, if you take the free plan, the functions are going to be part of the application. So even though it's a static web app, it's a client thing, you also have an API that you can deploy. Okay. Here, you see that the standard, even if you pay, it's very cheap, right? It's $3.64 per application per month. If you want what they call enterprise grade edge, which comes with some, guarantees that the web app doesn't go down more than, I'm not sure exactly, I think it's probably 99.99% of the time, etc., then you pay twice as much, but even twice as much is still very cheap. It's like, $7 per month, right? So quite reasonable. All right, I'm going to deploy that. Well, actually, we are all in Western Europe, so I'm going to deploy that in Western Europe so that I have less latency. And then you see for the deployment, I'm going to say I want to use GitHub. I already linked GitHub to my account, to my GitHub account, linked Azure to my GitHub account. And then I'm going to say, all right, within that, I have my own organization. Inside the repository, and now I need to give a repository where the code is. But at this time, I don't have that yet. So let's go into GitHub. And if I go into my own account here, what I'm going to do is create a new repository. And this repository, I'm going to call that test chat, okay? And I'm going to make it private. It doesn't matter because here I'm actually authenticated as Bugnion already, so I don't need to make this public. I can keep it private. And then after that, I'm going to create this repo, and I'm going to put my whole code inside there. So modern web developers do it using console, and it has to be dark themed, of course. I'm kind of boring, so I don't use console. What I'm going to do is I'm actually going to use something called Git extension, which is really what I do most of the time when I want to use GitHub or Git in general. It works exactly the same. I could do all that from a console. So I'm going to create a new repository in my folder here. And when the repository has been created, I'm going to open it. What did it do? Oh, sorry, it's on the other. Okay, so I need to create. It was on my other monitor here. All right. And then when it's done, I'm going to actually open the repo. And now I need to select what I want to commit. Sorry, it's always on the wrong thing. So what do I want to put there? Well, I want to have the git ignore. Inside the git ignore, amongst other things, I have the local settings.json. It's somewhere down there. Then after that, I told you I don't want to deploy anything from the web server because I just want to have the static content. So I'm going to remove here. Oops, actually, that's wrong. I'm going to add this, sorry. I'm going to deploy the index.html, but I don't deploy anything from the web servers. That was only for test here. I'm going to deploy my functions, okay? Taking great care of not deploying the settings and the secrets. And now I need to do something in the index.html because I'm deploying to Azure. I should probably automate that at some point, but I'm going to actually change this value to be the value, to be an empty string. And the reason why is because, like I told you, on my web server, it is running in a different, on a different port. So I need to specify that. But when I deploy that to Azure, everything is going to be on the same port. I'm just going to refresh, and then I'm going to deploy that. Okay? Let's give the best commit message of all times, which is first commit. I'm going to push that. And so what's going to, oh yeah, I need to configure the repo. So the repo is origin. That's just the first time that I need to do that. This is the URL that I copied. Save changes. It's going to get what it needs. And then when it's done, it's going to push the branch, which means that now my code is in GitHub. But now the magic happens because I have my repo here. If I go there and I check the repo, actually it's not here because of course I'm going to need to refresh. So what I'm going to do to trigger a refresh, I'm going to just change the organization here. In a real scenario, you would probably create your repo before you actually do that. So I'm just triggering a refresh of my, it didn't actually get it. So let's give it a second. Microsoft. Okay, now I want L Bugnion. Test-chat. No. Okay, so what I'm going to have to do, I'm going to have to refresh that. I'm so sorry about that. They changed the UI a little bit. Before it was actually more seamless, the way that I was doing stuff, but it means that I'm just going to reconfigure everything I did very quickly. This is a SignalR demo. Okay, I think I said test chat for this application. I take it for free. I put it in Western Europe. I take this organization, and I think that now it should see the new repo, test-chat. Yeah, okay, now it sees the repo. And now I can say, which branch do I want to deploy? I want to deploy main, okay? Build details, what is it? It's not Angular, it's not Blazor, it's actually Vue.js, okay? You see that you can also have static web app for things like Hugo or Gatsby, ViewPress, which are some static site generators. Those are pretty cool. I'm going to have to say, where is the application? So my application, essentially what I want to say is where inside here, where is this index.html, right? And if I go here in GitHub, it is going to be inside this folder called chat client web, okay? So I'm going to put that here. And now I need to say also where is the function application. And same thing here, I'm going to go inside there. And this is why you have the CS project. That's what it wants to know, where it has the .NET project. So I'm going to set that. Output location, I don't need it. Now this is ready. Okay, it's going to just take a few seconds to actually create the static web app. Now it was just validating my entry, initializing deployment. When it's done, it is going to tell me, all right, deployment in progress, a few more seconds. You can, by the way, always follow what's happening in this window in Azure, okay, in case you're not familiar. And now it is deployed. And now I get here a brand new application. I can actually go and browse. If I browse, I have nothing. The static web app is live, but I don't have anything yet. What did the static web app do? It actually created a GitHub action, and now it is running it, and it's going to do the whole deployment of my index.html with everything that it needs, all the static stuff that you put in the repo, and it's also going to deploy my Azure Functions, compile it, deploy the result, and everything. That's going to take just like a minute or so. So let's go back to the slides quickly. I think I'm going to run a little bit long. I hope you don't mind, but it's cool stuff. So Azure Static Web Apps, like I said, this is my favorite service in Azure these days. It is really cool the way that it's set up, because I showed you, right? When you have a code change, this GitHub action or this Azure DevOps pipeline, depending what you use, are going to be created automatically, and then they are going to build and update your content. You have static content, HTML, images, JavaScript, CSS. Like I said, anything that is a little bit bigger than a few kilobytes, you're probably going to have it in a blob storage. It's cheaper, okay? It's easier. Like this, you keep your application small. The cool thing is that you can also have an API, which is Azure Functions. And here, even though we did the Azure Functions in .NET, you can actually do them in JavaScript or in Java or in something else if you prefer. Key features, I don't ask you to read everything here, but remember that you get a free SSL certificate. It's a big deal. Anybody who forgot to renew an SSL or a TLS certificate for their website can tell you that it's a big deal. You get some custom domains, even in the free version, so you can have, instead of running into a specific domain here, which is randomly generated by Azure, you can have your own domain. What do you have? You can also have some authentication providers. So here I'm not showing that because anybody can chat. But if you wanted to restrict certain routes, certain function endpoints to certain people, you can do it with a role-based authentication. So basically you say, all right, so that person who authenticated in Azure using GitHub or using Twitter is now recognized as a user, but that person only has access to, for example, the talk function, but he cannot, for example, open a new chat channel or something like that, essentially. So you can totally manage that in a very seamless way. All right, so by now, I think that the function is done. You see that it's green, so it's perfect. So now if I go in my static web app and refresh, now I see something. Okay. Oh, why did it fail? You have an ID? I cannot hear you really. The thing that happened here is that, do you remember, I need the connection string for that to work. I need to tell my application where is the SignalR service. On my local host, I did that, but I told you that's not going to go to Azure because this is secret, right? I don't want to have that in GitHub. So what I'm going to do here is that I need to configure that. So I'm going to go into my, my test chat static web app. And here inside the configuration, I'm going to add the value. And the value is here. So I'm going to take, in that case, I'm going to use the same service. So this is going to be the same connection string. In a real life scenario, you would probably use a different connection string for your production than for your development environment, right? So I'm going to add this. I'm going to save. Okay, just takes a moment to save. Actually, what happens in the background is that the function application is restarted. Takes just a few seconds for that to happen. Once it is updated, I should be able to go here, refresh, enter my name. This 44 is not relevant, it's just an icon. And now you see that it worked, all right? So now it is connected. So that's really cool. But what's even better is that I'm going to allow you to try it out. So what I'm going to do is that I have prepared a short link, which I just updated. And now if we go here, if you want to take your phone out and scan here the QR code, okay, try it out. And I'm going to close that so the QR code is bigger. You should be able to see on your phone the website, which we just deployed. You should also be able to enter your name, and who you see, Martin, the first one. Martin deserves a big round of applause. Yay, bravo, Martin. It works. And hey, everyone from Zurich. Here we go, and you should get my message right now. So it works, all right? I'm going to shut this down before somebody has some weird ideas. It's a risky demo, but I like it. Okay, do I have another 5 minutes, or do you need to go and eat pizza? You okay with 5 minutes more? Somebody give me thumbs up or thumbs down. Thumbs up. Okay, cool. So let's talk quickly about Timekeeper. So like I said, the idea for this application came from an actual application that we're using. Why did I develop Timekeeper? Well, essentially, I don't know if you know that that dude here. It's Abel Wang, good friend of mine who unfortunately passed away. I mean, he passed away last year, but just before he passed away, I had the chance to interview him. And we had this show called Hello World at the time, and we had some segments of 5 minutes. And one of the stuff I proposed as an idea for a segment is say, hey, I want to interview people at Microsoft, like amazing people, right? And 5 minutes is really short. So when Abel starts talking, it's really hard to interrupt him because he has so many amazing stories to tell. But I was limited to 5 minutes. So I decided, well, I need a way to tell whoever I'm interviewing that the 5 minutes are up, but without interrupting them, because it's not polite, okay? So that was kind of the idea. So here, the idea is really, how do you keep time without interrupting whoever you're talking to, okay? How do you keep everybody on the same clock? And I'm Swiss, so of course it speaks to me, right? To have time, time management system. Also passing messages to the presenter is a little bit like a teleprompter, etc., etc. And this is what Timekeeper does. So here you see a little bit of demo. So if you go to timekeeper.cloud, you can actually try it out on your own. This is running for free on Azure as a demo, but you can actually use it. A lot of people use it for actual production scenarios. You see that you can define multiple clocks. Okay, there's actually a video on timekeeper.cloud showing you how to do that. And then you can also use it a little bit as a teleprompter, totally powered by Azure Functions and SignalR. And this is a Blazor application, but I could do the same thing in HTML if I was in JavaScript, if I was so inclined, okay? I also added a polling mechanism. So in the new, in version 0.7, which is not quite the latest, you can also add polls, and then you can have people voting on that. So you tell people, hey, if you go to this address, and then you select A, B, C, D, and then the presenter can see whatever the people chose, including number of votes and number of people who select the correct response. So this is cool. And then I also added a small chat application, mostly because I didn't want to use Teams when I'm talking to my presenters. Teams is pretty heavy. And also there is also an access issue. I cannot get everybody into Teams. So I have this simple, unprotected, I would say, chat application going on. Actually, it's not totally true that it's unprotected. It is protected by authentication. And basically, if I allow to start a chat, it's going to work as a host. And of course, I can have multiple hosts. So we use it a lot internally for different things, such as LearnLive, which is a show that I'm producing, especially for the polling scenarios. This is a show that I'm producing now. We also use it for just meetings, like the Global Experiences All Hands meeting, which is the organization I belong to at Microsoft, is using Timekeeper to keep track of time, because we have some very short segments. And before, we used to be overtime a lot when we had those, all hands meetings where many people were presenting. Now we are still overtime, but by a little. So that's better, much better. Okay, so that's kind of the idea. So if you want to try Timekeeper, you can actually go to timekeeper.cloud. So timekeeper.cloud. Okay. It's going to allow you to log in. Actually, there is no login here. It's open to everyone, so you can try things out. From time to time, I clean things up, so I go and delete the sessions. Be warned about that. It takes here a moment to start because there is an Azure function in the back, so it has to wake up if you want. Once it's done, it works well. So you can go here, you can create sessions. You see a lot of people are actually using it to try things out. Some of them just for tests, but some of them for actual meetings and all that. And you can even use emoji as session name, which is kind of fun. This is actually a birthday cake here, apparently. So why not? You create your new session, or you just log in into an existing session. And then after that, you can go and create additional clocks. You can configure your clock. You can say what should be shown when it goes overtime. I make it blink, and then you can be a little bit obnoxious and say, shut up, I want pizza. which is exactly what you are thinking right now, etc., etc. And then I can also say, all right, when it's at 30 seconds, it should turn red and start blinking. So essentially a good way to tell people that they are where they are in terms of time. Very quickly, just to show you the illustration of what we did. This is a connect application of the chat client, okay? And here you see what it does. It creates a connection. Create the connection is exactly what we did in JavaScript. Essentially, we send the message here to negotiate, all right? And then we get the negotiate info back that we deserialize. And using this, we go and we create a new connection. And then we say what happens when it's reconnecting, when it's reconnected, or when it's closed. So essentially, that allows me to have some error management, okay? And then at some point, when I'm ready with my connection, I'm going to say, when I have received chat, I'm going to receive a chat. When I have request all the chat, I'm going to send all the chat. So those are the targets that we saw before. I start the connection, and then when the connection is started, then basically I start receiving my chat messages here, etc., etc. Okay, so same thing. The code, by the way, so if you go to timekeeper.cloud, I have a link to the repo. It's open source. Feel free to take the code and check it out. The link is there, including also a video explanation of how it works. All right, so that's it. This is what we talked about. Okay, JavaScript, events, SignalR, connection, WebSockets, publishing to static web apps, Timekeeper, a little bit of Blazor. I didn't really talk about Blazor, but Timekeeper is running with Blazor. If you want to know more about SignalR as a service and Azure Function, we actually have a Learn module. This is all for free, so you can just log in there. You don't even need an Azure account actually to try it out. This is at this URL. And finally, everything you need is really down there. gslb.ch/nnug22. Okay, this is where you find the slides as well as the different repos that you need. Timekeeper is at timekeeper.cloud. Thank you so much for your attention. I hope it was interesting and useful. It was really fun for me to show this, and I'm really happy that I had a small view that I can actually see you. So thank you so much for that. I hope you have fun. I hope you have pizza. I'm not going to have pizza, but I'm definitely going to grab some food. Now, if you have questions, I'm happy to answer them. Thank you so much for your attention. My name is Laurent Bugnion. I work for Microsoft, and it's really a pleasure to be here with you today. Thank you.
Thank you so much, Laurent. It was really great session here. So I think the easiest way here is if you ask the question and then I can repeat it to Laurent.
Yeah, I have one. When you're doing the SignalR stuff and you have multiple tenants, like messages to kind of be grouped on a tenant level. Maybe sometimes you want things to go across. So what kind of abstractions do you use? Do you use these hubs, for example, for each tenant, or how would you approach that?
Mm-hmm. I did hear the question. I'm not sure. Do people watch online as well? Should I repeat the question or no?
Yeah, you can do that.
Okay, so in case somebody didn't hear the question, right? You're talking about different tenants and basically how to kind of cross communicate, right? So of course this is more of an architecture question, and it's not really just for SignalR, right? It's pretty much for all the service we have. It can get tricky. I would say rule of thumb is for most things I use a single SignalR service for a given application. So if I have an application, so I link it more to an application than to a tenant if you want. If I have an application like Timekeeper, for example, I will probably have one SignalR service. And after that, within that, I can have multiple hubs for sure. I use hubs actually to create groups of people. Like for example, right now you cannot really do that, but in a future version of the Timekeeper, I'd like to have the possibility to say, all right, so I will have one host, but then I will have one host can manage multiple groups of guests, right? And that could be a scenario for a hub, for example, where you say, okay, I have one group of guests which is in the hub, and then like this, they receive the messages only that are directed to that group, right? Across tenants, essentially, what you would probably have, if you have the possibilities, have some kind of a neutral tenant when you run your SignalR service, right? Which is then used by all the others. That could be a possibility. I think this is probably something where at some point we should probably sit down and use a piece of paper to really understand the problem you're trying to solve. But yeah, off the top of my head, it's probably something like that, right? Does that make sense, or does that not really make sense?
It makes sense, but I'm still kind of confused about what I'm going to do. So yeah, because we do have a single application that supports multiple tenants. Yeah. So and I don't want things to bleed between tenants willy-nilly, and say that we are able to scale. I probably don't want a browser for one tenant to kind of filter away messages for 999 others. Yeah. So I probably want to kind of restrict the message flow a bit.
Yeah, no, I understand. I think I was a little bit confused by your definition of tenant. I was thinking of Azure tenants, but no, now I understand what you mean. So I think hubs are a good way to solve that. Hubs are really separating the traffic. So, and they are separating the traffic at the server level, right? So you make sure that the web browser of group A or tenant A, if you want to, if you want to call it that, doesn't get messages. It's not filtered by the SDK. It's filtered really at the server. The target, on the other hand, is not, right. The target, the client gets the target and then decide what to do based on the message. But if you go and check the network tab in your web browser, you will see the message, right? So you don't want to do that. But yeah, no, hubs would be a good way to do that. Yeah, separate your different groups of users with a strict separation. Thanks. Cool. Any other questions? All right, I guess you all want pizza, and hopefully there is also something to drink. Thank you so much for having me. It was really fun. I'll definitely send the link to the YouTube video, to Twitter and social when it's up. Thanks so much for organizing those events. I think everybody's very happy to meet again in person, and hopefully next time I'm in Oslo, we'll have a chance to meet in person as well. Thank you.
Yes, looking forward to that. Thank you so much.
All right. Bye-bye.
Bye-bye.